But just for an answer on a quiz or on a test, if you have any doubts about how many decimals you should keep, just ask me and I'll tell you at that time. Let's go on to the second one because it's a kind of interesting variation on the exponential equation. First off, note it is an exponential equation. The exponents are the variables are in the exponents, but this time it'd be very hard to isolate an exponential because you're going to get an exponential and another number on the other side, but we make an observation. The exponent on the first term is twice the exponent on the second term. That's what we had whenever we had equations quadratic in form and we used a u substitution. So let's try that here. I'll set u equal to 2x. Sorry, that's not right. I'll set u equals to e to the 2x. Then u squared is equal to e to the 2x squared, which is you multiply the power times the exponent, so that's e to the 4x. So this original equation is in the form u squared minus 3u minus 18 equals 0. That factors quite easily. We need a negative 18 on the end with a negative 3 in the middle, so I'll say a negative 6 and a positive 3. And that gives me u equals negative 3, u equals 6. Now, of course, the original equation had no u. What we're looking for is x, so we now do the substitution. For u, we put in e to the 2x. So now we have e to the 2x equals negative 3, and e to the 2x equals 6. We've isolated our logarithm in both cases, so our exponential in both cases, so we can now take logs of both sides. Since the exponential base is e, I'll use the log base of e. ln of e to the 2x is equal to ln of negative 3. Well, we can see right there this isn't going to work. We're not going to be able to raise e to the 2x power and get a negative. The log of negative 3 is undefined, so this is not going to lead us to a solution. Let's try the other side. ln of e to the 2x equals ln of 6. 2x equals ln of 6. X equals ln of 6 divided by 2. That's ln of 6. It's not the ln of 3. It's the ln of 6 divided by 2. If you try the ln of 3, it will not work. ln of 6 divided by 2 gives you 0.89587, so I'll say 0.896. In this last one, we again have two exponentials, and if we try to isolate one of the exponentials by dividing by the other exponential, we end up with an exponential in the denominator on the other side. Well, that doesn't sound good, so let's see if there's some other way to approach it. You have a rule for exponentials that says if you multiply x to the a by x to the b, you get x to the a plus b. So here I've got 3 to the x plus 2 times 3 to the x, so that should give me 3 to the x plus 2 plus x. Now I have just one exponential on the one side, and that is 3 to the 2x plus 2. Now normally I'd be looking to take the ln of both sides or the log of both sides, and you could certainly do that here and finish the problem. But I observed something. I observed that 81 is 3 to the 4th power. That is, it's 9 times 9. 9 is 3 squared. 3 squared times 3 squared is 3 to the 4th. So I can rewrite this as 3 to the 2x plus 2 equals 3 to the 4th, and now I have the same exponential base on both sides. Now I can use the one-to-one property. So that tells me 2x plus 2 is equal to 4, 2x is equal to 2, x is equal to 1. That doesn't cause me any problem. I can certainly do 3 to the 3 times 3 to the 1 is 81. That's certainly a true statement. So that is the solution to the problem.